about, this probe is called Following Jack, and it's all about speed and acceleration and motion. And so I'm going to read the probe out loud, and then we're going to talk about it a little bit, and then we'll talk about our vocabulary. So it says, Josie and her little brother Jack are walking side by side eating ice cream cones. Josie stops to talk to a friend. While she is talking, Jack's ice cream cone starts to drip at a steady rate as Jack walks away. When Josie finishes talking to her friend and realizes that Jack is no longer next to her, she looks down and notices these drops of ice cream on the ground from Jack's ice cream cone. So then, those are the dots of Jack's melted ice cream. Josie needs help figuring out how Jack was moving or walking while she was talking. If Josie follows the drips, what can they tell her about Jack's motion? So, what is motion? Does anyone know? Buff, do you have a...
Motion is a change in position.
Okay, so can anyone predict what they think was happening to Jack's motion as he was walking? Was he walking faster? Was he walking slower? Did he stay at the same rate?
It's like his steps were getting bigger.
His steps were getting bigger?
Because when the dots are like all clumped right there, that's probably why he was just standing there. And then when they space out, it's probably him walking away.
So go ahead and read through the answer choices and maybe talk to a partner about what you think is the right answer. And I'll give you 2 minutes to do that. Emily, what do you think the right answer is?
I put C.
Okay, you're fine. And why'd you put C?
Because it looks like that he was starting slow, but then the dots are spaced out equal.
Okay. Courtney, what do you think?
I think so too, because they're, because they're starting to get equal. It starts little and then it gets wider.
Okay, so do you...
Slow to fast.
Okay, so you think that he was walking slower and then kept up a fast rate. Okay. So we're going to talk about the vocabulary now. Constant speed is when an object will cover the same distance over a regular interval of time. So if you think about it, Jack had a constant speed when his dots were spread out. C is the correct answer. So you're looking at his dots, and first they're very close together because he's walking slow. So you think it's dropping and he's walking really slow, so they're going to be closer together. But as he spreads out and walks faster, they're going to be more spread out because he's going to be covering more distance. So then we talk about uniform motion, which is when an object moves in a specific direction at a constant speed. So those go kind of hand in hand. So when you think about a constant speed, you're going to have uniform motion because you're moving at the same rate. Now we're going to try and do this. Who wants to be my volunteer? Okay. So we're going to drop beans as we walk, and we're going to time it out and see where your beans end up. Okay.
Do you want me to like?
Yeah. Okay. Alright. So these are for you.
Grab these one, yeah. So there are four fundamental.
And then,
One is
I
gravitation.
guess we can walk.
So we're gonna start back there and walk.
Yeah. I guess we could do it over here. And just
Sorry.
go like straight down. So when I'm gonna give you a time. So every time I say drop, you're gonna drop a bean.
How fast do you want me to?
So first you're gonna walk slow, like normal speed, and then when it gets to, let's say, when it gets to 6 seconds, walk faster. Okay, so I'll tell you what. Alright, ready? Go.
Drop one?
No, walk.
Sorry, I
Drop.
didn't mean to do that.
You're fine. Drop one. Drop it. Drop. Alright, now walk faster. Drop. Drop. Alright, you're good. You're good. Okay.
Slipping out of my
Yeah.
While she is talking, Jack, I think I had sort of
Something that doesn't bounce so well. I'm just trying to make them more like. Okay. All right. So now I'm gonna go and I'm gonna put a post-it note at each beat. Okay.
That's so wrong.
You were like, go, 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 go.
They were sliding out of my fingers. I had too many. Nope. Nope. I will release one.
And Judy, what do you think happened when she was dropping the beans? Okay, now everyone go ahead and go look and see what you think was happening as.
Maybe that's over there. Moving past here. Yeah, my strides. Well, slow down. I'm getting tired over here.
Okay, so why do you think it appears that they're further apart?
Going fast.
She was going faster. Okay, good. So now we're gonna. Okay, so now go to your next page. There's 2 pages. And we're gonna look at this probe. So it says, Josie needs help figuring out what Jack was doing. Which of the following position versus time graphs best shows how Jack moved while he was eating his ice cream cone? So go ahead and look at those answer choices and think about what would happen on a graph when this was taking place.
Okay, it looks like most of you put C, so can one person explain your own words why you chose C?
So it looks like most of you chose A. Does someone want to explain why they chose A?
I chose A because it said at the beginning, like for C, that he started out walking slowly, so at the bottom is more slow, and then as it goes up, and then it levels out, so he was walking at a constant pace.
Okay.
He was faster. So that was
Okay.
awesome.
What about Judy? What did you get?
I chose D because it showed that he started slow and then slowly built up, because he didn't go slow and then fast rapidly like A would show. And so then it became steady out here.
Yeah, you're right. So D is right. Yeah, that's hard. Graphs are very hard to understand.
Out there maybe, but
Yeah, so it's important to really understand the difference between speed and acceleration. Emily, do you want to try and explain the difference between the two?
I think speed can be constant and acceleration is going faster.
Okay, yeah. So acceleration is when you're actually picking up speed, and then your speed is how fast you're going. It's important to understand those when we're looking at our graphs so that we can graph out all the points correctly. So now we're going to draw this graph. So I'll draw the one that was on there.
But where's D constant?
I'll show you. So it's kind of hard to see because they don't label the axes, and that's why it's really hard to understand the graph. But basically what's happening is that this is the position. So this is the distance that he covers, and then this will be the time. So over time, so let's say, because we don't know his exact interval, let's say it was just 1 second. So 1, 2, 3, and then as he goes, so it's low because
It's position.
it's position, and then it goes up,
I got it now.
and it doesn't really show it leveling, but it essentially it would if it kept going the constant speed. but it just
I'm
shows.
confused about something. What do you
Okay.
mean by position?
So his position is like where he is, like his distance would be his position.
Oh, okay.
So how far he goes.
Okay.
How would uniform motion be apparent in this? Can someone explain that? Exactly. So at first he starts out accelerating because he's walking slow and then he accelerates here. So his point of acceleration is here, and then as he goes up, his uniform motion like gets constant. So if it flattened out like